Welcome to page 3 of our grade 6 advanced post-course test. These are all the skills that should have been mastered by the end of 6th grade if you wanted to be an advanced math student. And here's the cool thing is you can get to the point where maybe in 6th grade you weren't that comfortable with math and you were sort of middle of the road. And then maybe 7th grade, your teacher or your maturity or things started clicking and now you understand math a little bit better. And now you're revisiting these concepts and you understand them much greater to a fuller detail. So that's oftentimes how we do that, or why students start doing better in a subject is a little bit more mature, a little bit older. Your brain has developed a little bit more. So let's talk about number 38, finding the surface area of an object. So surface area, there's a number of techniques to do this. Mr. Mack likes this formula. Surface area equals lateral area plus base area. Well, what does that mean? Lateral area, base area. Lateral is around, right? Your lateral area is your waist. So it's around the object. So the lateral area would be the 4 rectangles that go around this base. So we're talking about this rectangle. We're talking about the front rectangle. We're also talking about this left rectangle and then the back rectangle. So that would be the lateral area. If we chopped off the top and the bottom and sliced it down, it would look like this as a net. And oftentimes it is described in terms of a net. So you have these 4 faces that goes around. So if we folded it, you would have this. So that lateral area is a rectangle. It looks like this. Right, and we have we have our 4 sections. That's front, left, right, and back. So, and then we're going to add the base area. And the base area is actually, we have 2 of them. We have a top, which is a rectangle also, and we have a bottom. So you have the left, you have the back, you have the right, and then you have the front, and then you have the top, and you have the bottom. That is the surface area of the object. So 2 base areas are 2 rectangles also. So if that's what the surface area consists of, okay, so how do we do this? How do we find this? Well, this actually ends up being the perimeter around the object. The perimeter, because it's going to be 6, 4, 6, and 4, because it goes 6, 4, 6, 4. So this base of this rectangle is going to be 6 plus 4 plus 6 plus 4, or 20 inches. And then the height of it is going to be 8 inches. So it's the perimeter times the height. So P times H. Oftentimes you will see that substituted in for lateral areas, the perimeter times the height of the object. And then the base area, so that's going to be, because this is a rectangle, so it's base times height, so 20 times 8 is going to be 160 inches squared. And now let's look at the bases. The base is 6 by 4. And both of them are going to be the top and the bottom will both be 6 times 4. So it's base times height times 2, because we have 2 of the same. So 2 times 6 times 4 inches is going to be 24 inches squared, and we have 2 of those. So we have 160 inches squared plus 24 inches squared times 2 is going to be 48 inches squared. And we'll add those together, and we get 208 inches squared is going to be the surface area of this rectangular prism. We should also know what it is. How do we decipher it? Well, rectangle is the base, and if we have 2 bases, then it's a prism. If it's a polygonal base, we have prisms. If it's a circular base, we would call it a cylinder. Now this has 1 base. It's triangular. So this is a triangular pyramid. Pyramid because it only has 1 base. So the surface area, how many bases does it have? Well, it's going to have 4 bases. It's going to have 3 in the top. You have a right, a left, and a back. And then we have our base shape. Now this is an irregular, and you're not going to be, because I guess we will go under the assumption that each of those sides of the triangle, that it's going to be a equilateral triangle, because it does not give any other information. So we can make the assumption that each of these triangle sides are going to be congruent. So we have 3 faces. We have 3 faces plus the 1 base is the surface area. And those faces, the left, right, and the back, are all triangles. So technically we have 3 triangles. An area of a triangle is base times height divided by 2. So of the triangles, we have a height of 17 feet. And we have a base of 8.5 feet divided by 2 times 3. That's going to be the faces. So base times height divided by 2 times 3, because we have 3 of them. And then we're going to add our base, also a triangle. So we still, again, have base times height divided by 2. The base, again, is not only the base of the faces, but the base of the base is 8.5 feet. And then the height of that is 7.4 feet divided by 2. Okay, so now let's simplify. 2 is not going to go into any of those. That's going to be ugly. So we'll divide it by 17. Half of 17 is going to be 8.5. And so we have 8.5. 8.5 times 8.5. 8.5 feet times 8.5 feet. Let's do that. 8.5 times 8.5. 25, 40, 42. Move the space. That's 40. 64 plus 4 is 68. 5, 2, 12, 7, 2 decimal places. So that's 72. So we have 3 times 72.25 feet squared. Now we're going to simplify this one. 2, we'll divide it by here. That's going to be 37. 37? Yeah, 37 feet. And now we have to multiply these two. 8.5 times 3.7, 35. 56, 59. Move the place value. 15. That's 1, 24, 25. So 5, 14, 11. 2 decimal places plus 3, 1.45 feet squared. We have to multiply 72.25 times 3, because we have 3 of those. That's just the area of one of the faces. That's a lot. That's a big one. Well, it is 17 feet. So let's do that. Let's do 72.25 times 3 is 15, is 7, is 6, is 21. 2 decimal places, so that's 216.75 feet squared still, plus 31.45 feet squared. Now we're going to add 216.75 plus 31.45. 5 and 5 is 10. That's 12. That's 8. That's 4. That's 2. So 248.2 feet squared would be the surface area of that triangular pyramid. I don't need that 0. That drops off. Okay. That's the surface area. Find the volume. So volume, this is a rectangular prism. Volume equals big B times H, where big B stands for base area and H stands for the height of the object from the base to the next to the distance between the two bases. So if I'm going to make this my base shape, and this is going to be my height, so the distance between the two bases. So my base area, well, the base shape is a rectangle, so I'm going to do base times height of the rectangle, and the base is 4/5 of an inch times 2/3 of an inch. That's my area of my base, and then I'm going to multiply it by my height, 1/4 of an inch. So what can I do here? I have multiplication and multiplication, so I'm going to see if I can cross cancel. That 4 and that 4 can cancel, and that's all I'm left with. So that's 1, because 4 goes into 4 once, 4 goes into 4 once. So 1 times 2 times 1 is 2. 5 times 3 times 1 is 15. And then I have inches times inches times inches, or inches cubed. So the volume of this rectangular prism is going to be 2/15 inches cubed. Not bad, right? Pretty straightforward. Write a positive or negative integer that represents the situation. You have a debt of $36. So that would be negative 36. Debt is owing. You owe people money, so that is money you don't have. Negative, it would be, write a positive or negative. So it would be negative 36. Easy as that. Which temperature is colder? Negative 164 degrees Celsius or negative 165 degrees Celsius. If we look at that on a number line, this being 0, this being hotter, the higher the temperature, hotter to the right of the temperature, and then to this direction would be colder. Colded? Nice. Colder. Nice. That's cooler. Hot, cooler. So when we look at the number line, you're going to have, the numbers will increase as you go here. So you'll have negative 164 and then negative 165. Numbers are increasing. So this is going to be the colder. Negative 165 degrees Celsius is colder. That is colder than negative 164 degrees. Graph the number and its opposite. We always do the number line like this. We always place 0, 1, 2, 3, 4. 1, 2, 3, 4, -4. So if we graph it, we have to put a dot above the graph. So graph the number, and it's opposite. This is indicating which number we are graphing. Numbering it or labeling it is not graphing. 3.2. So we're going to have 0. We're going to have 1, 2, 3, 4. So 3 and 4, or positive 3.2 is going to be between 3 and 4. -1, -2, -3, -4. So -4, -3. So -3.2 is going to be there. It's opposite. It is between -3 and -4. Complete the statement using greater than or less than. So Mr. Mac's not bad with his fractions. I already know where they stand. So this is this is 0. You have -1. Let's extend this a little bit. You have -2. You have -3. Here, you're going to have -2 and 1/2 is going to be between -2 and -3. And -2 and 1/4 is going to be between -2 and -2 and 1/2. So which one is greater? The numbers to the right. This is always going to be greater, is going to be to the right. Lesser is always going to be more to the left. So if we have these two numbers, if we're going to do -2 and 1/4 in green, if we graph that, we'll put that one there. That's -2 and 1/4. This is -2 and 1/2. So which one's smaller? So lesser is going to be -2 and 1/2. So here are our signs. It's always going to, our sign, our inequality sign. Technically, this is less than. This is greater. So we can do it either way. So we're always reading it left to right. So they're always going to eat the bigger one. So which one is bigger? We knew that -2 and 1/4 is greater. It's going to eat that one. So we would have a greater sign. -2 and 1/4 is greater than -2 and 1/2 when we read it. Again, on the number line, if we want to draw it on the number line, 0, 1, 2, 3. Not good on drawing my number lines. To proportion. This is -4, -3. Heck, we even need a -5 here. -5. So let's see where -4.4 is going to be. I don't know, right about here. -4.4. Did I draw dashes? Yes, I did. Okay. And then -3.2 is going to be between these two. -3.2. Let's make a little dot there. So which one's bigger? Which one's bigger? Well, this one's to the right, so it's going to eat that one. So we're going to use a less than sign because -4.4 is less than -3.2. Find the absolute value of -87. So absolute value wants only, it means distance. It wants to know the distance, and technically the distance from 0. Okay, so what is that distance? What is the distance of -87? So -87 is there. What is its distance from 0? So what is this distance from -87 to 0? Well, that would be 87 units. So the absolute value of -87 is 87, because that's how many units it is from 0. Absolute value wants to know the distance from 0. How far away is it from 0? Cool. This is a bizarre question. this one had Mr. Mac a little weird. So the balance is negative 27. So debt would be equal to $27. Yeah, you're $27 in debt. It's a really, really weird question. You will not see this type of question in a traditional math. You won't see it in high school. You will see balances of negative, and you will see that if you have a balance of negative $27, you are in debt. You owe the bank $27. But to use an inequality sign, I don't know. So if your balance is greater than negative 27, then your debt is what compared to $27? Well, your debt is less than $27, right? Your debt is below 27. I don't know. If your balance is greater than negative 27, then the debt is going to be less than 20. I don't know. I think that's the right answer. And then if your balance is below, then your debt is, what did I say for that one? Maybe your debt, 27 is greater than your debt. Your debt is going to be smaller than $27. If your balance is greater, I don't know. I really don't know what the answers to these. So your balance is more than negative $27, okay? So debt, is this the debt? 3 account balances are given. Are there 3 account balances? I don't understand. Your balance is greater than, I don't know what it is. That doesn't mean, I don't know. When your balance is less than 27, then your debt, your debt is not going to be greater than $27. That would give you positive. I think you're still less than, I don't know. I'm going to say less than. I don't know what debt, what is your debt? I don't understand. Is this the debt? This is such a poorly worded example. So if you didn't understand 48A, B, and C, I get it. I totally understand. Except for 48A, I think you should get 48A right. B and C makes no sense to me. I get this. Okay, your balance is less. That means your balance, you're in debt. So your debt, but you is, what? Okay, would we say our debt is greater than $27? Meaning you owe more than $27? I'll do that. Maybe that's what they're trying to do. Okay, but you have to be careful. Debt is representing the negative part. And then if your balance, so let's say your debt is less than $27, right? I don't know. Dumb question. There are bad questions. Math books can make really dumb, bad problems. All right, reflect the point negative 4.4, negative 4 comma 4. Remember, coordinates are written x, y. This would be the x coordinate. And this would be the y coordinate, or the y position. And that is based upon this being the x-axis and this being the y-axis. So if we're going to find this point, negative 4, 4, we have negative 4 on the x value and 4 on the y. So we'll go to negative 4 in the x. Here's the origin. So x would be 1, 2, 3 positive values. X will be negative values. Y will be positive values. Y will be negative values down here. So negative 4 on the x and positive 4 on the y would take us to that point. So negative 4, 4 on the, so that's our point. Now we're going to reflect this point in the x-axis followed by the y-axis. So we're going to reflect it over the x. This is x. So we're going to take this distance and we're going to reflect it over the x. So it's 1, 2, 3, 4, 1, 2, 3, 4. So this is the point after reflecting over the x-axis. Now I want to reflect it over the y-axis. This is 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3, 4. And that final point would be 4, comma, negative 4. That's the point. So 4 in the x, negative 4. So if I reflect it, I get 4, comma, negative 4. I like reflections. I love coordinates. Coordinates are fun. Reflections are fun. Rotations. Those are all transformations. The vertices of a quadrilateral, it's a four-sided figure, are A is at 10, 7, B is at 2, 9, C is at 3, 1, and D is at 10, 2. Draw the quadrilateral in the coordinate plane. Okay, so A is 10 on the X, 7 on the Y. That's right here. That's point A. B is 2, 9. That's right there. That's going to be point B. C is 3, 1. That's going to be right here. And D is 10, 2. And that's D. And then we would connect the dots. It's always good. If it's a figure, the vertices, those are the points. So we draw that. We connect that. We connect that. And we connect that. And that would be the quadrilateral, a four-sided figure with the points A, B, C, and D with the appropriate locations. An archaeological map uses a coordinate plane in which the coordinates are measured in meters. The vertices of the chamber are -3, -4, 6, -4, 6, 1, -3. Find the perimeter and the area of the chamber. So first things first, let's draw those. So -3 on the X, -4 on the Y. I think takes us to that. And then -6, 1, 2, 3, 4, 5, 6. Nope, sorry, 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. And then 6, 1. And then -3, 1. So we have that is our chamber. Let's connect the dots. That was a horrible connecting of dots. And let's fix that one. Boom. All right, so that's our chamber. So first thing we need to find is the perimeter. The perimeter is going to be length plus width plus length plus width. The other formula that you might see is 2L plus 2W. Another formula you might see is 2 times the quantity L plus W. So the length in this figure is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units going that way. In meters, 9 meters. And 1, 2, 3, 4, 5 meters is the width. So let's put that in. So P equals 2 times length, which is 9 meters, plus 5 meters. P equals 2 times 14 meters. Meters plus meters is meters. And then 14 times 2 is 28 meters. Meters is one-dimensional, so perimeter is one-dimensional, so it'll always be m to the first, meters to the first. So that was our perimeter. Now we want to find the area. Area is a rectangle, so length times width. The length, as we said, was 9 meters. Width is 5 meters. 9 times 5 is 45. Meters times meters is meters squared. So area is always going to be two-dimensional, so our units are going to be squared. Good? Write the word sentence A number P is at most 4 as an inequality. So a number P is at most. It's no more. It can't be bigger than, so it has to be less than or equal to 4 at most. So if I plugged in 4, it would be equal to it. So that would be a true statement. If I did 5 less than 4, no. So this is the proper sentence, is at most. So it can include 4, but it can't be greater than 4. So the proper notation or word sentence or inequality is P is less than or equal to 4. Tell whether x equals 3 is a solution of x over 3. So we have this inequality, and we're going to plug this value in for the variable. 3 over 3 less than or equal to 2. I'm already doing the problem. So 3 over 3 is 1. Is 1 less than or equal to 2? That is true. So x equals 3 is a solution. Is a solution to the inequality. Graph the solution of the inequality. So first we have to solve it. So we have, much like equations, we want to isolate the variable. 1 is being subtracted. The inverse of subtracting 1 is adding 1. That leaves you with x is less than 4. So I'm going to graph that on an inequality or on a number line. I don't make you do the dashes. I just want you to put 0. You must put 0 and you must put your solution. Now, inequalities, we have to remember that when you have less than or greater than, you're going to have an open circle because it's not including. It's infinitely close but not including. And when you have less than or equal to or greater than or equal to, we're going to have a closed circle. And that closed circle is including. That means we want to include the border. So x is less than 4. We're going to have an open circle, values that are less than. I look at x as my solutions. The solutions are less than 4. So I do that. Now I'm going to graph above the graph so I can see whether it's open or closed. When people put that down in here, let's connect these for a second. Let's group that. So when I put it down in here, it's kind of hard. Is that an open circle or a closed circle? Is the arrow going to the left or the right? We don't have that problem when we graph it above our number line. So always important to put it above so we can see whether things are open or closed or going to the left or to the right. Here, this is our first fractional problem that we have. We haven't had a fraction multiplying a variable. So when we talk about inverses, let's do this. The operation, and then the inverse of that operation. So addition is easy. Subtraction, the inverse of addition is subtraction. Subtraction, the inverse of subtraction is addition. Those are super easy. We know those real easy. Multiplication, the inverse of multiplication is definitely division. That's the easy one. But there's multiplication. There's another inverse for multiplication, which is multiplying by the reciprocal. So reciprocal is another form of an inverse of multiplying. And then the other one is division. The inverse of division is multiplication. So those are really easy. Now, just to give you a little advance, anybody know what the inverse of squaring? If you have a variable being squared, do you know what the inverse of that? Square root, yes. And do you know what the inverse of square rooting is? Yes, squaring. So when you have a variable as being the square root of a variable, we would square it as its inverse. So important. I'm definitely going to deal with that this year. So instead of dividing, I see a lot of students dividing by 7/6. Who wants to do that? Yuck. I don't know if that's how you spell yuck, but that's how Mr. Max is going to spell yuck. We don't want to do that. it's way easier to multiply by the reciprocal. Multiply by the reciprocal. Any number multiplied by its reciprocal equals 1, leaving us with x, or a coefficient of 1. That's a form of isolating. And here, we would not multiply 7 times 6. We're going to cross cancel here. We have common factor. 7 goes into 7 once, 7 goes into 7 once, leaving us with 6. So now I have to graph it on a number line. I draw my number line, I draw my 0, I show my solution. Is it open or closed? It's an open circle because it's not including. And I want values. My solutions are greater than 6. So I'm going to graph to the right. That's it? That was it? Nice. All right. That wasn't too bad of a video. Hopefully you're doing well on these. Hopefully you're learning something new. By the way, if you want to know that one, let's do this. What would the inverse of cubing be? Cube root, yes. And the example is, hey, if you have x squared equals 25, how do you isolate the variable? You would take the square root. And whenever you do that, you also have to introduce a plus minus. So the square and the square root are going to cancel each other because they are inverse. And then you get plus or minus 5, because a positive 5 squared would give you 25, and a negative 5 squared would also give you a 25, positive 25. So the solution set would be plus or minus 5. So we'll leave you with that to ponder and to think about, and we will go into more detail this year in 8th grade.